Alright, in this movie we're going to try to demonstrate how easy it is to create a brand new steady state simulation in the Pipeline Simulator 3.0. And so as a little background, at some point some months ago we made a promise to the management that we would set this up so that any process engineer with some knowledge of pipeline hydraulics, of course, would be able to set up a new simulation from scratch by themselves in 15 minutes or less. So let's see if we can do that today, and so let's get started. Now, just to show you that I'm not cheating at all, I'm going to show you what it is that I'm starting with. I've made this new folder in my projects folder called 15 minutes, and here's all I have to go on for my new project. My client has given me the ground profile data basically, and along with that he's told me that he wants a certain throughput on his slurry pipeline. But other than that, I don't really know anything about it. I don't know the pipe diameter or the station locations or types or anything at all about that at this point. So this is all I have, the ground profile and the desired throughput. So let's see what we can do and how we do that in the simulator. Okay, so first we're going to go up here to Tools, and we're going to start our project wizard. And I'm going to browse over to my 15-minute folder right there, and that's because that's where I want to work. I want to work out of that folder. And then I need to create my configuration database, so I'm also going to call that 15 minutes. Create new. Next. And then we can give the pipeline a name, 15-minute pipeline. The owner of this is the I Am in a Hurry Company, LLC. Always in a hurry. Okay, now we're to the point where we need to define our pipe, the pipe and profile data page in the project wizard. And remember, I don't know anything about this project except what my client gave me in the spreadsheet. So the way I'm going to go about this is I'm going to use the pipe and profile wizard. So I'm going to click that to get started. Go over here to the ground profile page. Now here's where I'm going to get back my spreadsheet that my client gave me. And I'm going to grab those two columns with kilometer posts in one column and elevation in another one. And I'm going to put that on my Windows clipboard, and then I'm going to come here and I'm going to paste it in. Okay, it says it pasted in 3,000 plus rows, and it gives me a little picture here of the ground profile, and I could look at the data here if I wanted to. So far so good. Alright, let's go to the next page. Now at this point I must pick my pipe material. Currently in the wizard we support only steel pipeline, although the simulator itself does support HDPE. To get myself started, I'm going to pick this X65 grade, and then I'm going to go next. Now this client told me what he was looking for is about 2.25 million tons per annum at 65 weight percent and a slurry SG of 2.2 approximately. And we're going to assume an availability of 90%. That results in a flow rate of 200 cubic meters an hour. So let's let this system help me pick the pipe size. I'm going to look for a velocity of something around 2 meters a second. I'm going to pick this 8-inch pipe right here. Okay, so we're going to go next, and now I need to get my wall thicknesses. So far I have, you can see here, steel X65, 8-inch OD. So for my 8-inch OD, I can pick from these standard wall thicknesses. I'm just going to pick this schedule 80, and I'm not going to line this pipe, not at this point anyway, and I'm not going to worry about flanging for now. Okay, so I have my new profile, and I'm going to call this profile 8-inch because that's 8-inch pipe. Okay, I'm going to save that. It says it saved it successfully. That's good. And so now I'm back to my main wizard, and I have my 8-inch file specified. Let's pick that again. It looks like I didn't find it. There we go. Now I got my green X. It says it found it, and the file is valid. Okay, so let's go forward now. Now we need some stations. Well, again, I don't know much about this pipeline, but it's pretty long, and I'm going to take a wild guess that I'm going to need a PD pump station at the head station for now. I can always change it later. So I'm going to create my PD pump station, and then I'm going to put something at the terminal, and I'm going to put a choke station there. I don't know if I need chokes or not, but I'm going to put it there for now. I'm going to create that. There's my 2 stations. That's the minimum that I need, a station at each end. So now I'm going to go forward. I'm going to go with these default slurries and water, and I'm going to finish that off. Okay. Now let's open that and see what happens. So let's browse up to here to 15 minutes and open that database and see what we get. Okay, so we had a pipeline full of water with way over pressure. We are up around over 52,000 kilopascals at PS1, so that's definitely not going to work. Let's put some slurry in there to make it, well, even worse. Okay, so now the first thing that is pretty clear that we probably need to do is add another pump station in there and see if we can get this line down farther. So let's go here to stations and add station, and let's put another PD pump in and call it PS2, and let's put that right about in the middle of the pipeline at one's about 75, and then let's open that up. And it slipped back to water again. Okay, well that's a lot better, isn't it? But we still have way too much pressure here at well, both pump stations. Now I could change the pipe diameter. That might make some sense. Or I could add another pump station in there. So let's try another pipe diameter. Okay, I'm watching the clock here. We're about 8 minutes into this, so we got a little bit of time here. Let's do another pipe in profile. Let me grab my data from the spreadsheet again and paste it in there again and go next. Now this time I'm going to pick X65 again. I'm just going to go straight in here and pick my 9-inch pipe. Okay, and for a 9-inch pipe I'm going to pick the 1/2-inch wall, not flanged. Okay, and this is going to be my profile with 9-inch pipe. Okay, done. Now let's load that in there. File, open, pipe and profile, 9-inch, and let's put the slurry back. Well, that's a heck of a lot better. I like that one better, but I still do have a little bit of a problem here with too much pressure at PS1. So let's see. Well, we could fool around with pipe some more. We could try a 10-inch pipe, or we could try putting another station in there. Let's try another station. You know, a good place for that might be somewhere near the top of this mountain. That looks to be about, well, let's see, a kilometer. If you look up here, you can see the kilometer post where I'm pointing. So that would be about kilometer 26. Let's try that. I'm going to add a station, another PD pump station. I'm going to call it PS2. Well, we got a PS2. I'm going to have another one though. And I'm going to put him at kilometer 26 and create it. And put the slurry back again. That's pretty decent there. That's pretty decent for a first go around with the pipeline. Let's change this to PS3 so we don't confuse ourselves. Okay, and now I've got PS1, 2, and 3 and the terminal. And let's put the slurry back. Okay, now I've got a rough idea of what this pipeline might look like. I have a little bit of problem here with my suction pressure at PS3, but I'm not going to worry about that right now. I have one error and 8 warnings here in my configuration checker. My error has to do with my rheology, which does not add up to a total concentration fraction of 100%. However, I don't need to worry about that because right now I'm using the equivalent fluid model as my gradient model, and it does not care about the rheology. So I really don't need to worry about that, although I could fix that problem if I wanted to. Okay, so I've got about 4 minutes to go. I'm pretty much done here. I might want to look and see what some of the economics of this are. I can go to the economics viewpoint here, and here's my total steel weight, which is about 13 metric tons. And my total power is, my kW is about 4,800 kilowatts. So that's a pretty reasonable shot, and that at a pipeline steady state simulation. And that took us about 12 minutes. Okay, now the question you might ask yourself, is there any validity to what we did here? Is he just playing tricks? So let's check that out. Okay, by the way, the stopwatch is stopped now. Okay, so I beat the 15 minutes and we're at about 12.5 minutes now. That includes a lot of talking too, by the way. But what I'm going to do now is I'm going to open the real project that this was emulating, Dahongshan project. This was the final design for Dahongshan. And the station locations are different, but the number of stations is the same. Notice PS1, 2, and 3 in the terminal. We won't worry about the PMS stations for now. What would be interesting to do is look at the economics of this. Okay, so and this is a final design, so this is optimized, and so they came up with about 10 metric tons of steel, whereas I had 13, and they got 5,200 kW, whereas I had 4,800. So you can see that even though we spent only 12 minutes on it, we got definitely in the ballpark for a rough cut at a station design.